For this problem, we're going to prove a conditional statement in two different ways. First, using direct proof, and then by proving the contrapositive. So a conditional statement of the form P implies Q has what we call an antecedent P and a consequent Q. And for direct proof, we're just going to take the antecedent P and let it be a given, and then the new goal will be Q. And whereas for proving the contrapositive, we're going to take the negation of the consequent Q and make that a given, and the negation of the antecedent P will be the new goal. Okay. So here's the statement we want to prove. Suppose A and B are real numbers. Prove that if A is less than B, then A plus B over 2 is also less than B. It's a good idea to try and sort of intuitively understand why a statement is true before you prove it. And for this one, we can do that with a number line. So if we're assuming A is less than B, so I could draw my A over here and B over here somewhere. And then A plus B over 2, that's just the mean of A and B. And so that would be right in the middle here. And you can see that from the picture, that's clearly also less than B. Okay. So good, let's try and write down the logic for a direct proof. We have a given that A and B are real numbers, and a goal, which is a conditional statement. And we will, for a direct proof, we'll take the P, right, the antecedent, A less than B, and move it over as a given. And the consequent Q will become our new goal. Bring down our other given. And now we somehow have to get from this inequality over to that one. And it looks like adding B to each side would be a good first step. And we can do that since A and B are real numbers. If the first inequality is true, then the second one is as well. And then to get to the end, we just have to divide each side by 2. Okay. So that finishes up the logic. Now let's try and write out the proof itself. First thing we did was to move the antecedent over as a given and take the consequent as our new goal. And the way we represent that in the proof is to say, suppose A is less than B, and then our new goal, we're going to show that A plus B divided by 2 is less than B. Okay. And then from there, all we had to do was add B to each side to get from here to here, and finally divide each side by 2 to get to our goal. So first we'll say adding B to each side, and I should say I want to explain that it's this inequality I'm adding B to each side of, so I'll say each side of the given inequality, right, not the one we're trying to prove. We get that A plus B is less than 2B, and then dividing each side by 2, we get what we want, namely A plus B over 2 less than B. Okay, and that finishes that proof. Now let's go back and prove the same statement using the method of proving the contrapositive. Okay. So we start with the same given and goal, but this time, with this conditional goal here, we will take the negation of our Q and make that our new given. And the negation of a less than inequality will be a greater than or equal to inequality. And we will take the negation of our P, and that will become our new goal. Okay, so this was negation of Q, and this new goal is negation of P. And now to get from this inequality to that one, it's sort of doing the backwards direction of what we did for direct proof, right? So the first step is going to be to multiply each side by 2, and then from there we just have to subtract B from each side. Okay, so let's write this proof. We first remember, just took the negation of the consequent as a given, and the negation of the antecedent as our new goal. And so we will say, suppose, oh, well, we should actually advertise the fact that we're going to prove the contrapositive. Okay. And then we'll say, suppose a plus b over 2 is greater than or equal to b. And we're going to show that a is greater than or equal to b. And the other two steps were we multiplied each side by 2 and subtracted b from each side to get to our goal. So multiplying each side of the given inequality by 2, we get a plus b greater than or equal to 2b. And finally, subtracting b from each side, we get what we want, a greater than or equal to b. And now we're finished.